Hello everyone, I am P. Manoj Kumar, Assistant Professor at G. Polarity Engineering College, Karnool. Welcome to the ETABS tutorial series. In the last video, we have discussed regarding the introduction of the ETABS and the interface of the ETABS. So in this video, I am going to cover the analysis of simply supported beam with the help of ETABS software. So for this analysis of simply supported beam, I am considering one simple supported beam which is having one end is roller support and one more end is hinge support. So the span of the beam that I am considering 6 meters, and this beam is subjected to a concentrated load at its center, that is 20 kilonewton load, and here I am having 3 meters of span, and here also having 3 meters of the span. So before going to do the analysis of this simply supported beam in the ETABS software, here I am trying to find the reactions at the supports. I am trying to find the reaction at its supports. See here, at this left support, here I am considering it as B, this end I am considering as B. So at this left support, my reaction will be, that means RA is equal to 10 kilonewton and RB is equal to 10 kilonewton. So this can be, we can do based on our basics of the strength of materials subject, and here I am trying to draw the shear force diagram with the help of these three loads, with the help of reaction and concentrated load. So here you can see, you can get the shear force diagram like this, two rectangular boxes. So here you will get positive shear force and here you will get negative shear force with a magnitude of 10 kilonewton here and 10 kilonewton over here. Now I am trying to draw the bending moment diagram. So this bending moment diagram will be like a triangular thing, and this, at this center we will get maximum bending moment, that is 30 kilonewton meter. So 10 into 3 meters, we'll get 30 kilonewton meter. So this is the shear force and bending moment diagram we can get in the ETABS software too. So let's start the analysis of simply supported beam with this example by using the ETABS software. Let's see, I am trying to open my ETABS software. Here I am having ETABS software. So double click on the ETABS 19 icon. It will take time to open. So after opening this ETABS software, here I am clicking on new model. Here I am clicking on new model. So after that you'll get this insulation model. So in the last video I have covered how to change the units over here, so that here I am using this option, and here matrix SI system, Indian, IS 800 2007 and IS 456 2000. Click OK button. Then you'll get this grid dimensions, grid option. So this option also I have already discussed in the last video. So instead of selecting this grid systems, I am going to choose the blank option for this video. That means with the help of blank option also we can make the model of the any structural element in the ETABS software. So that is we are going to do in this video. So you just click on the blank option, then click OK button. So here we have chosen the blank option, right? So that you will not get any grid systems in these two windows. This is two-dimensional window and 3D view over here, right? So after getting this interface, you just click on edit option. So here I'm going to teach one more option with in the edit option. So that is edit stories and grid system. Click on this option. So here you can see here we are having at the top one story data, how many stories that you need. Those things you can edit here itself. And grid system also we are having. Here we are already having that grid system 1. So this grid system I am going to modify with the help of modifier show grid system. Click on this option. So again you'll get this entire things. Okay. So here I need to create grids. So how we need to create the grids, I'll explain with the help of a diagram itself. So here you can see in the grid system, you can choose here. So this is my grid A. This is my grid A. And one more grid here we are having. So that is at B, I am going to considering as grid B. This is grid B. That means here in x-axis we are having two grids. This is x-axis. We are having two grids. One at A, one more at B. So this grid system I am going to create over here. Create in this grid data, right? So here we are having two options. One is display grid data as ordinates. One more option is display grid data as spacing. Here I am considering first option, that is display grid data as ordinate. What does it means? So that means ordinate means here the starting grid A, I am considering it as zero ordinate, and the spacing of the second grid between A and B is 6 meters. That means with the help of ordinate you need to give 6 meters distance for this B grid. That is the thing here I am going to add. So first click add button and give grid name as A. So as we have already discussed about the grid A, and you just give it as zero ordinate. That means this is my starting grid. Here in the top right corner you can see the grid A is already generated, and one more grid that I need to give is B. So one more time you just click on this add button. So there you will get automatically B grid. So here you can see it is automatically, you can see here it is 0, but we need to give this dimension as 6 meters. So then you just click on to the next. Then you just see here in the right top corner the distance between these two grids is 6 meters. So this is how you can create the grids with the help of display grid data as ordinate, right? So in the Y grid data you can add only one grid is there, that is here I am giving as 1, and also that Y grid is located at 0 meter itself. So this is how you can see. This is my grid in Y direction. This is grid in X direction, right? So if you want, you can increase this bubble size with the help of this option, bubble size option. You can change the size of the bubble too, right? So this is about my grid data for the simply supported beam. I am just clicking on to the OK button. Then here I do not need this many stories, so that I need to modify this stories by clicking the modify or show story data. So here I am deleting this option. Right click on this option and so go to the delete story, then delete existing structured story. Here also you just delete this story 2. Up to story 2 you can delete all the stories. So you need to have minimum 2 stories in this ETABS software. If you are trying to delete the story one also, it cannot be deleted. It can show that too many story levels are selected. At least 2 story levels must retain or remain after deletion. That means you need to keep these 2 stories same. You should not delete all these 2 things. Okay, so this is my grid option. Now you can see we are having this grid system. So after getting this interface, you just go to the elevation option, elevation here, elevation, and click onto the one option, then click apply. Then you can see this is the elevation. So this is the elevation. At base we are having elevation, means you are seeing from this point, you are seeing from this point, then you can see base point and this top elevation. This is the story 1 and this is the base. Here you can see, here you are having base and this one is story 1. Now we need to create the simply supported beam with the help of this selecting tools. Here I am going to select the draw beam option, here. Click onto this button and draw a beam by clicking the 2 options, right? So next press escape button. Now we have created beam, and now we need to create the supports at this grid point and support at this point, right? So here I am unselecting all the things. Now I am need to give the support at this grid A. So for that, first click on to the at this point and go to the assign option. Here we are having joint. In that joint you just click onto the restraint, So here in the left support, as you can see here, in the left support we are having rollers support. Left side we are having roller support. So you just click on this 3rd option, then apply. Okay, here you can see this is my roller support. Now I need to give hinge support at the point B. So for that you just click the mouse at this point and go to the assign, joint, restraint. Again click the 2nd option. This is related to the hinge support, and 1st option is related to the fixed support, and this 4th option is related to the internal hinge. Now I need to apply this hinge support to the right side of the beam. So just click onto the apply, click OK button. Then you can see this is my hinge support. So I have already created a simply supported beam with the help of roller support and hinge support. Now I need to apply concentrated load of a magnitude 20 kilonewton at its center, So for that one, you just select the beam and go to the assign option. There you can see frame loads are there. Here we are having 4 kinds of loads. One is joint loads. That means whenever you want to apply the loads at exactly at the joints, then you can go through the joint load option. Frame load means in between between the beams, if you want to give the loads, then you can go to the frame loads. Shell loads means it is slab loads, or all are the things will comes under this shell loads. So right here I am going to choose the frame loads. Why? Because I need to give the concentrated load at its center of the beam, that means that is in between the beam. So then I'm choosing this frame load option. In that frame load option also we are having 3 options or 4 options. One is points, that means concentrated load, distributed load, temperature loads, and open structure wind parameters. So in this problem I am going to give only one concentrated load, that is at its center. Then I am clicking on this point load. So by clicking on this point load, in the first option you can see load pattern name. Here we are having 2 kinds, one is dead load and live load. Here I am giving dead load option itself. There is nothing much difference for this analysis of simply supported beam of these with these 2 options. So you can choose any one of these option. Okay, next, forces we need to give. We are not at all trying to give moments, right? Then only choose force option, and that force also is acting towards the downwards, that is gravity direction. So that is the reason here I am choosing this gravity option. First we'll go with the gravity option. Okay, next, here we are having on right side 3 options. One is add to existing loads, replace existing loads, delete existing loads. Right, delete existing loads means whatever the loads that you have applied in the beam, you can straight away delete those loads with the help of this third option. Or else what is the difference between these 2 options? First 2 options, that is add to existing loads and replace existing loads, that I will clearly show you over here. I'll clearly show you over here. And see, this is the point load distances given, and at what distances what is the load acting over here. Here you can see. So under that we are having again 2 options. One is relative distance from end 1 and absolute distance from end 1. Right, here I am using only one concentrated load, that is at its center, so that you cannot understand this relative distance from end 1 option. So that I am going to use this absolute distance from end 1. So this first option I will explain how this option will be helpful in the ETABS software, that I will explain in the next video. So by considering multiple loads acting on the simply supported beam again itself, right? So first initially you just go through the absolute distance from end 1. So here, so exactly at the center of the beam we are having one concentrated load. We are having one concentrated load, that is 20 kilonewton load, right? So that you can give any load in between the beam, that means from A to B you can give any number of loads. So with the help of this absolute distance from end 1, here I am giving 3 meters distance. That means at 3 meters distance from this point A we are having 20 kilonewton load. So that is the reason here in the first option itself I am giving 3 meters distance, and at that 3 meters we are having 20 kilonewton load, that is also given over here. See, if you in the first time if you are trying to add load over the beam, then you can choose any one of these 2. So after that, if you add more number of loads including the previous load, then you go to the add existing load. Or else if you want to replace the previously given load, then you just go through the replace existing load option. So here you can see initially I am giving add to existing loads. So that means here I am applying the load. So then you can see, here you can see 20 kilonewton load is added for this beam at its center, right? If you want to replace the load with the help of 30 kilonewton, instead of this 20 kilonewton, you can select this option, second option, replace the existing load. So what is existing load for this analysis problem? So 20 kilonewton load is my existing load now. So for this existing load, instead of this 20 kilonewton load, I am trying to give 30 kilonewton load, so that you just go to the replace existing loads, then click on apply. Now okay, sorry, just select the beam and click apply button. Then you can see 30 kilonewton load is replaced in over the 20 kilonewton load. Or else if you want to add one more 20 kilonewton load for this existing 30 kilonewton load, you select this option, add to existing load. Now select the beam and apply. Then you can, here you can get 50 kilonewton load. You can see here. See here, 20 kilonewton and 30 kilonewton load both are acting over here. So I think it is not clearly visible. Then I'm replacing 20 kilonewton load initially. So first select the beam and apply. So then this is 20 kilonewton load. Now I'm trying to give one more load at 4 meters distance with a magnitude of 30 kilonewton load. If you replace this existing load, so if you add this again, here I am giving again at 4 meters distance I am adding one more 20 kilonewton load, so that you can add existing load. You select this add to existing loads, then apply by selecting the beam. Then you can see added. So this is the difference between these two options. Now I am just replacing this load, existing load. Okay, sorry, every time so now I'm going to assign the load with the help of frame loads again. See, at 3 meters distance with the help of our previous diagram. So I am adding this beam load. So this is my I have created my simply supported beam, which is subjected to a 20 kilonewton concentrated load. Now this is over, right? So I am closing this one here. See, if you want to increase this font size, you can change that font size also by clicking the options button, options menu. So graphics preferences, here you can increase this font size, maximum font size. Here I am giving 10 points and click OK. Then it is increased. Then it is increased. If you want to change, again you can change, no issue. Right. So this is my simply supported beam. Now I need to analyze the beam. So for this, go to analyze option and first click onto the check model, select and select all the options, then click OK. Then you can see model has been checked, no warning messages were generated. So this is model checking is over. Again go to analysis. This is do the run analysis, or else you can straight away you can use function key, that is F5. So for the run analysis option, okay. So by clicking the run analysis, so before that you need to save the file. Here I am giving file name as simply supported beam, simply supported beam. So I am creating one more file name, that is, on the desktop I am going to create one folder with the name of Manoj, then here I am placing this into the button. Now the analysis is going on. So this is the analysis message. Okay, you click on done button. So now you can see this is the deformation of the beam, our simply supported beam. So now I want to see the reactions first. You go to the display frame load assigns, so that you can see the load, what is the load exactly acting on the beam. You just use this option and apply. Okay, here you can see this is my load acting at the center. So now for this load I need to see the reactions of the supports. Then go to the reactions, display support or spring reaction option, then FZ option. You need to choose the FZ. Why? Because our shear force is in Z direction. Here you can see in Z means upward direction, X is this one, and perpendicular to these two axes one more option is there, that is Y direction, right? Now I am going to see this. See, okay, so for 20 kilonewton load, so what is the reactions that we have? See here, our reactions will be 10 kilonewton itself, but here what we are having 17. Instead of 10, it is showing that 17.07. That means here this beam self weight is considered over here, but in our PPT we are not considered any self weight of the beam. Only we have considered 20 kilonewton load of concentrated load, and for that 20 kilonewton load we will get 10 kilonewtons of reactions, that is on both ends you will get 10 kilonewton load. So how we can change this, how we can neglect this self weight of the beam means, so there is one option to neglect the self weight. So before going to do that one, so again you just see the moments, how the moments are acting and how the shear force diagram is. So here you can see I am showing you that this is the shear force diagram. See here slightly one uniformly varying things that you can see, varying shear force diagram you can see. So go to the moment again, see this is the thing, and also you just show the values option. Then 40 kilonewton meter is my shear bending moment diagram. That is not the thing, right? See here, only in the modeling I have given only 20 kilonewton load only, but instead of that 20 kilonewton load, so including that 20 kilonewton load, self weight of the beam also included for this analysis of simply supported beam. So we need to neglect the self weight of the beam, so then only we can get exact values as we calculated in the slides. Okay, so now I'm going to neglect the self weight of the beam. So before that you just unlock this model, click on this lock button, then only you can unlock the button, then only you can do the any changes. So now go to the assign again, go to the frame option, property modifier is there, so select the beam. In this property modifier mass is given as 1, and that means weight of the beam will be multiplied with 1 and weight and mass will be multiplied with unit. So here I am making these two options are 0. So then click apply button, then OK. So now again do the run analysis for this beam. Wait a while, it is coming. Okay, click done button. So now you can click the reaction button, then click apply. Now you can see, so this is my reaction values, that is 10 kilonewtons. This is 10 kilonewton, right? So again, you see the shear force, click apply. Okay, then you can see two rectangular boxes. One is positive, one more is negative. And if you click this at any point of the beam, if you click right button of your mouse, you can see this is my simply supported beam and subjected to 20 kilonewton. In previously, before neglecting self-weight, we have seen that the entire beam is subjected to a uniformly distributed load. That means that is nothing but self-weight of the beam, right? For this beam, you can see this is my reaction, that is 10 kilonewton load at each end, and this is the shear force diagram. This is the shear force diagram. That shear force will be 10 kilonewton load, and maximum moment at its center is 30 kilonewton meter. So all the details we have covered in this ETABS software for the analysis of simply supported beam by neglecting the self weight of the beam. And here you can see our deflection of the beam at the center is 0.299 mm. So this is my analysis of simply supported beam. So in the next video, we'll go to the analysis of simply supported beam subjected to a multiple loads. So thank you.